Hi, good morning folks. This is Mike from Unknown Tech, back with another video on the Home Lab. This series we're going to go over the core services as it pertains to the Home Lab. So if we go to the blog, you can see here I have some posts on the Home Lab. What I want to do is go back to this diagram here and just cover some of this really quick. So I'm going to talk about the core services, not so much the advanced Kubernetes services, which we'll get into. The good news is Nutanix Kubernetes platform was just released last week, so we'll be ready to go with setting that up. We're going to support the data services for Kubernetes, and I'm going to be installing OpenShift and Rancher as well on the cluster, as long as I have resources available, and we'll talk about that here in a few minutes. What I really spent the time on is really focusing on the right side and the middle here. So essentially, more so the right side. What I have here is I've created the core services, so domain DNS services. You can see here up top DC01, domain DNS to the right here, and down to the left you see DC02 on the NAS. So between my Proxmox server and my QNAP NAS running virtual station, I have a domain controller virtual machine running on running both domain services as well as DNS services. I also have on the Proxmox server running a container engine, which is not listed here, called Portainer. So Portainer is running basically on an Ubuntu virtual machine that has some resources assigned, CPU, memory, and disk. And within Portainer, I run a few containers. Some of those containers have to do with the observability stack. So I'm running Grafana on there for the observability. I'm not running Prometheus. I actually changed this to InfluxDB. We'll show you that here in a few minutes. And Uptime Kuma, which is basically shows the uptime of my services, is actually not running on Proxmox. It's running on my NAS. So I have to update this a bit. And the Home Lab dashboard I haven't built yet. Not really a big deal. That's kind of like a nice to have. And then of course you see these Nutanix services on here. Some of the services have been moved into the 3-node cluster. So for example, I thought it best to actually run NUS, which is the Files Object Service, to run it directly on the Kubernetes cluster for Nutanix that I have on my mini cluster running the Miniswarms and MS01s. And then the Haiku backup solution will also more than likely run on the Nutanix Community Edition nested on Proxmox. So I know this is a little bit confusing, so I'm going to walk you through what we have here, what I've built so far. So the first thing we do is go to Proxmox. So Proxmox is basically running, let's see here, a pretty beefy server. It's only one server. It's an AMD EPYC 64-core, 128-thread system. It has half a terabyte of memory and approximately around 11 terabytes of SSD storage, all different types. So you can see here to the bottom, I have FastVM, NVMe Fast, NVMe Ultra. So some of these are running SSDs, some are running NVMe, some are running Optane. So I have a mix of different flash technologies within the server itself, and you know, the system and that board, the ASRock board, which I think I talked about a few blog posts ago, really allows me to leverage all of the storage capabilities and the PCIe connectivity that AMD EPYC brings to bear right on this platform. So again, a ton of fast storage. I don't have to worry about bottlenecks as far as storage are concerned. There's no spinning disk in this platform at all. Even the TrueNAS server is all NVMe, which we'll talk about here in a few minutes. But essentially, let's talk about this VM here, UTech DC01. So again, this is one of my domain controllers, right, running Windows Server 2022, and that is DC01. Basically, it's my primary domain controller. And then as I go to my NAS, go over to my NAS here, and I go into Virtual Station. You can see I have one virtual machine, and you can see here I have UTech DC02, and that is running, of course, the secondary domain controller, again running domain services and DNS. I plan to have a third domain controller in the cloud. When we talk about extending the lab into cloud services in a different post, we'll actually do that and have that set up already. So we can show you how we can extend that in the cloud. That way I have 3 separate substrates where I have domain services running, and I have 2 different regions running those domain services. I don't have to worry about outages, for an example, right? So for example, as I go to my camp, right, or my other location, and I run my lab there, I want to leverage the cloud domain controller and the domain services here running through a VPN, right, a point-to-point IPsec VPN tunnel that is connected through the Ubiquiti solution, where I can actually obtain those DNS and domain services anywhere. So whether it's in the cloud or my main home here in the main home lab. So again, those are handling domain and DNS services. All right. So as we go back here, the next thing I want to talk about is the observability stack. So in the observability stack, again, I chose Grafana as basically the dashboard, so to speak, right? The visualization, and I, instead of Prometheus for the database, I actually chose InfluxDB. So let's talk about this in a minute. And I'm also using Telegraph, which I won't get into on this because I don't have that set up. I haven't installed but not set up yet. I actually was on the wrong host there. So let's log in here again, and we can show you. So essentially what I have is I have InfluxDB, right, as the time series database, and I have these buckets created. I have one bucket for now called Proxmon. Okay, so basically this is the Proxmon database and bucket that's a target for Proxmox server to send its metrics. So when you set this up, you create the bucket, you create an API token, right? The API token basically allows the connectivity to this bucket from Proxmox. So within Proxmon bucket, right, I'm feeding data from Proxmox into this bucket, the metrics. So if I go into my Proxmox solution, and I go under Data Center, and I go under Metric Server, you can see here I have Proxmon here. So basically what this allows you to do within Proxmox natively is send metrics, right, to the InfluxDB server, right, which is basically running as a container. And I'm using it over HTTP. Of course, I'll be using HTTPS, using certificates. I name my organization. There's my bucket, right? And the API key is actually put in here. And as soon as you do that, you will have data. So if I go into Proxmon bucket, you can see here under Proxmon, all of these different measurements are populating, right? So this is coming from the Proxmox server, right, and being fed into that. So now that I have the metrics being fed into InfluxDB, now I can go into Grafana and I can create my data source. And you can see here I have a data source called Proxmon, and Proxmon is pointing to the InfluxDB container using Flux, and I'm connecting to it over HTTP again. Probably not the best way to do it. Skipping TLS verification, which again needs to be changed. And I don't recommend you guys setting this up this way. This is just something I did quickly yesterday to get it done, to show you what the monitoring could look like. So basically I have the basic auth, the password, my organization, and my token to connect to InfluxDB. So now I have the token, I set up the default bucket, I do a save and test, and you can see here the data source is working. So then we go into dashboards, and here's where I had some problems, because when you create a new dashboard, you can import dashboards, right, either through a JSON model or through a Grafana ID. So if I go in here and do a search and do Grafana Proxmox dashboard, it's going to send me to the Grafana Lab site with a dashboard. And what you do is you either download the JSON file and append it within Grafana in the import dashboard, or you can upload the file, or you can append it here in the JSON codes model, or you can use the number So you go here and you can copy the ID of this, and you go back in here and you put the number in here, and you click load, and it automatically pulls in the information on the JSON and creates a dashboard. Now, the latest dashboard that you see here does not work with the latest kernel of Proxmox. Okay, so something happened where I couldn't get any data populating within the dashboard itself. And when I did a search on this, basically what I saw was there was a lot of people having problems in the 8.2.2 release of Proxmox, where there was a kernel update and it broke something from the server side. So basically what happens is when you go to the dashboard, let's go home here, go to dashboards, we'll choose the one I have. What happens here in the server, it won't pull out the server for Proxmox. So I had to use an older Grafana dashboard that actually somewhat works, still doesn't fully work. You can see here the running VMs has no data. I don't have any LXC containers, so there would be no data running on Proxmox right now. But the running VMs and some other data is not being populated. So basically, right now, I'm going to have to play with this to see if I can get it fully populated, or maybe build a custom dashboard that makes sense. But this is just for Proxmox, okay? This is my observability stack, so I need to monitor everything. I need to monitor my networking gear, my Nutanix solution, the services within Nutanix, right? Now, one thing that you cannot do, right, with this setup, in some instances, I can't send metrics directly to InfluxDB. Okay, so basically I have to use a tool or an agent, so to speak, that actually allows me to either pull data through SNMP or push data through an agent. Now, I am a big proponent of pulling metrics, not pushing metrics. And to be honest, I don't want to be installing agents on solutions like Nutanix, etc., to push data. And I think there's, in my view, I think pulling data is much better because I can encrypt it, I can protect it, I can control the data that's coming in, and that's what you really want. So what I have to do is I have to install a third piece called Telegraph. Okay, so Telegraph essentially allows you to either pull data through SNMP, right, or through plug-in customization that's already built into Telegraph, right, where it knows, right, how to pull data from specific sources like Cisco. There is no integrated Nutanix agent, or excuse me, Nutanix pull through Telegraph. I have to actually do this SNMP, and that's not very hard. I just haven't set it up yet, right? So basically, I'll be creating new buckets within InfluxDB that'll house my network data for Ubiquiti, my Nutanix data, all of my different other services, to include the domain controller, Windows, so I can get full dashboards running up on Grafana. This is just an example to show you that with Proxmox it's easy because it's built in. It uses InfluxDB as a metrics. You can install Telegraph agent if you wanted, or you can use SNMP for Proxmox, but Proxmox itself already has the ability to send metrics to either Graphite or InfluxDB already. So to me, not using Telegraph makes sense, right? I'm bypassing the use of Telegraph, sending the data directly to InfluxDB, and then to allowing that data source right within Grafana. Now, again, Telegraph will allow us to pull from other sources that don't have this capability like Proxmox does, and we'll push that data into InfluxDB, right, via Telegraph. Think of it as a proxy. It's not really a proxy, but think of it as a proxy. And sending that data into InfluxDB, and then I can come back into Grafana, add new data sources, and create buckets. So if I had a new bucket created, as a matter of fact, I wouldn't even have to do this. If I created different buckets, it'll automatically pull all the buckets through this one connection. And then what I can do is I can either create a new InfluxDB source if I wanted, call it Nutanix, create another InfluxDB source, call it Ubiquiti as an example, and I can have separate dashboards. I can come in here, choose the different buckets. It'll pull the data, and then I'll be able to have different dashboards for my different platforms within my home lab. So that's the goal. Of course, we're not there yet, but this is just basic introduction to my observability stack. Now, some people are probably going to ask, and some of you are going to ask, why am I not using Prometheus? To be honest, I think the InfluxDB is actually much better. I think it's actually more robust. I think it's easier to use, to be honest with you. And I may look at Prometheus down the road. That's something I'll look at. But I do like this TIG stack, which is basically Telegraph, InfluxDB, and Grafana. Now, one thing I also will be deploying is Loki for my logs. I haven't done that yet. And I need to have a syslog component where I'm sending all my logs to, and then I can generate alerts based on that log data. So that's something I have to work on as well. And again, this is all running in a Docker prod VM running on Proxmox, which is basically running Portainer. So I go to Portainer here, you can see the interface, and within the interface I have 3 containers. Again, it's not much. Let's go here to the containers, and I have Portainer itself, which runs its service as a container, obviously, right? And then you can see here I have InfluxDB and Grafana, and soon you'll see Telegraph in here as well as another Docker container. To be honest, when I deployed this, I probably will redeploy it and actually have one stack that actually deploys InfluxDB, Grafana, and Telegraph. With this right now, I have a stack that basically only deploys Grafana and InfluxDB, but I want a stack that actually does all 3. Now, what's a stack? Think of a stack as Docker Compose, basically. So when I come in here to Portainer and add a new stack, I can actually add a Docker Compose file within the web editor, name my stack, and then I can actually deploy the stack. Okay, now what I like about this is I can manage the stack right within Portainer, right? I get visuals, I get logs on what's happening. Now, again, you can go into your Docker host directly, and on that Linux, my Ubuntu virtual machine that runs this stack and all the other containers, and I can, use Docker command, to look at logs. But this gives me this visualization that I like, and it's something I can easily get understanding of what's happening. Something's going on with Grafana. I can look at logs. I can download the logs. So again, it gives me this nice visualization for your container. You can see here I have a couple different VMs here we didn't cover. So Scarif is basically my TrueNAS scale VM. I haven't logged into this in a while. This is a all-flash TrueNAS scale, so it's basically passed through the controller and passing through those physical NVMe devices to TrueNAS. Let me see if I have the login for this. I do. Okay. And I haven't used this yet, but this is essentially going to replace my hybrid SSD HD NAS downstairs in my rack. This is going to be all for fast video editing footage. So I'll be basically doing all my video editing, and all the data will be pushed to this TrueNAS device. And then what happens is as the final video gets completed and gets uploaded to YouTube, the video will then be pushed into basically colder storage, the archive hybrid QNAP NAS, to save on space and cost, basically, right? Because I want to make sure that this has the ability to use how fast it is, right? It's got 10 gig interface, NVMe. I will be adding a 25 gig interface to this server, this Epic server, okay, this Proxmox server, and I'd like to pass through that because I do have 25 gig interfaces on my 10 gig switch that I'm using for my aggregation. I have 2 25 gig interfaces on that. It would be nice to actually have a 25 gig interface on my PC and then one connecting to this. I don't really need it, but why not, right? If I have it, I should try to use it. So that's something I plan for later this winter, fall, winter. to see if I can get 25 gig from at least my workstation to this NAS, which will be, or even the Proxmox server itself, because I don't need to pass through the entire 25 gig card. I can pass through an interface to this TrueNAS and get 25 gig here, and then maybe use 25 gig for something else. As an example, I have, you can see here, I have a Chat RTX. I do plan on having some AI services within Proxmox, but most of the AI services will be running within Nutanix as part of our Nutanix Enterprise AI capability, and that's something that I'll be working on too this fall and getting up and running. So last VM that's running here is a nested Nutanix cluster. It's not a cluster, it's a single node, okay? And it's got a ton of resources, right? 24 cores, 100 and I think it's 192 gigs of RAM. And you can see here, I've actually passed through a pretty large subset of disks. So one for the HV boot, one for the CVM, right? And one for the data. So essentially, very large environment, and we'll show you that in a minute. So I have a nested Nutanix instance, and I also have a 3-node physical on the MSO1's Nutanix cluster. So 2 separate clusters. One is I'm calling management, right, and one is I'm calling cloud native. So let's look at those right now as we log into Prism Central. Let's log into Prism Central. And Prism Central, I think I've covered this, as you know, basically is the multi-cluster manager solution, right? And within Prism Central, you have what's called the Cloud Manager, Nutanix Cloud Manager services running, so what we call NCM. So within Prism Central, you have a ton of capabilities like self-service, automation, just a ton of, multi-cluster management, you name it, it's here. And I love the dashboard here. It gives you can customize this dashboard, by the way, and you can see here it monitors security vulnerabilities. You can see the 2 clusters I have. Let's just go back, so I don't want to go too much forward into all the details, because I love all the capabilities that this provides. But essentially, you can see here I have 2 clusters, one called US East Core. That's the single node running on Proxmox, nested on Proxmox, and actually where this VM sits. So within this cluster, right, as we go to VMs, you can see here I have NCM Core that's running on US East Core, right? So I have this Prism Central instance running there, and I also have, well, I won't get into this in a minute, but the main core cluster will also be running other services such as like Nutanix database service that's not deployed yet, and it may run the object service. I'm not sure if I'm going to do that or not, but I definitely will have some additional service capability within this cluster. So I go to this cluster, all right, and I don't have to go from here. I can actually go back to dashboard and actually go quick access. This is going to send me into the actual cluster itself, and you guys can actually see it, so I'll make it large here. And I have this cluster again. It's a single node. I didn't need to be multiple nodes. I needed to be a single node. Why? Because again, this is like lab solution. So the stuff I showed you before, had core services on it. You saw the domain controller was spread out, right? Those are core services that need to be protected. Again, I'll have one in the cloud, so that's something. I have other data that needs to be protected that's backed up on the NAS going to Backblaze, right? Which again, we'll cover all the cloud capability in another post as we extend the lab into cloud, or how you can do that and do it in a cost-effective manner. You don't have to spend all this ton of money and still be able to use cloud services. It's choosing the right services that make sense for you, for your home lab. And by the way, this goes along with production cloud adoption as well. I see this all the time. Customers, are now, which is good, really good to see, using a cloud smart approach to adopting public cloud strategy. And it really is moving away from this all or nothing type of mentality. I'm not sure where that came from, but this all or nothing mentality has gone away when when prices and costs came out, when risk came out, right? Things like that. When they realized that legacy solutions running in public cloud were not really the right way to go. Um, Performance, all of these things, they still matter, right? Architecture still matters. Performance, availability of your application still matter, right? Those are things that you had control over in your own data centers, and you lost some of that control as you moved to cloud. And so people are looking at this now as a hybrid model, and I see that as, you know, foreseeable future for a long time, including cloud native technologies, which we'll talk about in another post. But the reality is that, you know, there is a use case for even cloud native solutions, Kubernetes, etc., on-prem as well. All right, let's get back to this. So you can see here I have this cluster here running Community Edition. It is running the latest version of Community Edition, which actually just released, I think, 2 weeks ago. And this is based on the latest 6.8.1 Nutanix code. So it has all the capabilities that the production 6.8 has. Now, okay, some things obviously you guys won't have access to unless you're a Nutanix employee or a customer, is obviously some of the advanced capability like NCM, NKP, et cetera, within Community Edition. Community Edition, you'll just really have this cluster and Prism Central. And that's pretty much it for now. But since I'm a Nutanix employee, obviously I get access to all of the software to be able to demo and show you guys what this looks like. So again, this is just running one VM for now, actually 2 VMs, one is a CDM. But it's just running Prism Central, which I'm in, which I logged into here, right here. Okay, so again, this will again be running some NDB services later, more than likely object services, and I think some other services like Haiku for backup, for VM backups, right, to the NAS, etc., that I want backed up. It don't necessarily have to be pushed off site. I may have, the beauty about Haiku too is, right, I can back up. It's integrated within the platform, where I can just tag up a category, and it automatically backs up that VM to Haiku, and then from Haiku I can actually send it off to an object service, and then from my Nutanix object service on-prem, I can have that tiered into something like a Amazon S3 as an example, which is what I will be doing, right? So again, just another example of where you can leverage the cloud, extend the cloud services to protect some of your critical data, and also leverage some of the services capability of other regions. So again, home labbers, we typically don't have other data centers, right? We are the most limited user of technology, and so the cloud really allows us to kind of extend beyond the limits of our own personal home, right? Our own personal one site issues, right? And failure domain, and being able to actually extend that into public cloud. Okay, the other cluster, let's get out of this one. Okay guys, this cluster here is the cloud native cluster that I put together based on the minis forms. You can see here there's 3 hosts, and these are MSO1s, upgraded to 96 gigs of RAM each, all flash. You can tell there's a ton of storage. I want to say, yeah, there's 9 TB of storage capacity, highly available. This is basically going to be running all of the Kubernetes solutions here, NKP, OCP, and Rancher, hopefully. Definitely NKP and more than likely OCP at the very least. So there's something else that's on this cluster as well that I'm running that I decided to run locally instead of on the core cluster, and that's Filer. So you can see here I have a file server here, and you can get the details here. Let's go to File Console, and right now I have 1 TB assigned to Filer, basically 3 nodes. I have no usage right now because nothing's connected. But they are basically 3 file service VMs spread across the 3 nodes. And they also have, let's go back here. You can see the configuration. They have 4 cores and 12 gigabytes. So that's what we were at my starting point as far as the Filer. And I can go in here and I can scale these things up, right? I don't have to keep it at 4 and 12. I can scale them up, scale them out. More than likely, because I have 3 nodes, I'll probably just scale it up. But again, this is going to be servicing the read-write many persistent storage access for my Kubernetes solution. Again, this will be running files. You can see here the CVMs, right, 6 and 20. So this will probably increase a little bit too as I look at performance. You can already see the memory utilization being used here on all of these, so more than likely these will be scaled up a little bit. So if we go back to the cluster itself, look at the utilization, I'm hoping to get NKP, OCP, and Rancher implemented here. I don't know if I'm going to be able to do that with the amount of memory and CPU that I have available to this cluster. We will see. I don't have high availability. I mean, I have high availability turned on, but it's best effort. So again, I'm not reserving any resources for high availability. Again, I'm not that concerned on this side of the cluster. Again, this is all home lab and demo environments for Nutanix services, which can be easily rebuilt if I have to do that. What else? Oh, I will have Kubernetes running on the core side because NDK will be installed, which is data services, Nutanix data services for Kubernetes, and I need to have a failover target for the persistent volumes and the Kubernetes solution to show what DR workflow would look like. So I will be installing some Kubernetes solutions and NKP on the core side as well to be able to do that. But mainly this cloud native cluster will accommodate all of the Kubernetes workloads. The core will also house virtual machine workloads to demo connectivity into NC2, to do things like migration demos, DR demos, and things like that. So again, that's kind of the goal, is to kind of have this one-stop shop for demonstration purposes. Nutanix does have hosted POC, demo environments, etc., but I like to have my own because I have complete autonomy and control over it. I don't have to worry about resource requests, things like that. I'll always have this resource. Typically when I'm on customer calls, I'm talking to customers, if they have a question on some feature function, or if I'm going over something and I just want to show them what it looks like, I can just go on my home lab and demo it very, very quickly and not have to worry about environments or the availability of environments that's shared across all of the field from a resource perspective. So again, that's the Nutanix side of it. Again, we still have to feed this, the metrics and things, back into InfluxDB via Telegraph. So that'll be something I'll be working on. One of the things I didn't talk about was another observability tool or uptime tool I call Uptime Kuma. So that's what it's called. It's basically a monitor to monitor your service availability, whether it's up or down. You can see here I have my Ubiquiti solutions, my cameras, my NAS, the Nutanix solution, Nutanix Cloud Manager, the clusters, all connecting back to Uptime Kuma being monitored for uptime. Okay, and I like this because I get a real view of what's up and what's down. I can have this up in the corner on my second screen to monitor it. I can even trigger alerts, things like that. But this is actually running on my NAS, the actual QNAP NAS, as a container. So let me just log in here and see if I can log in here and I can show you exactly what I'm talking about. Let me get my key here. Multi-factor authentication. And so when I log into this, one thing I did notice about this QNAP NAS and my Google Authenticator, there definitely is a delay. Like my other solutions are very, very quick. When the number changes on the Google Authenticator, I'm able to use it right away. But with the NAS, for some reason, there's a delay typically. That's why I got that that error there. So let's go to Container Station. And you can see here I have one container running, and that's Uptime Kuma. And Uptime Kuma, right, is running here in a Docker container. I can run single node like Kubernetes solution on here if I wanted to. Again, this is an older NAS. It only has a 4-core first gen Xeon D processor. It has 128 gigs of RAM. And so basically I'm really focused on this solution really servicing storage, and that's really it. And of course the backups to Backblaze. I think it's located here. All right, you can see Backblaze here is connected, and the jobs, right, that are done. So these are jobs that I set up to Backblaze. Again, Backblaze B2 is very, very reasonable from a price perspective. I'd have to find out exactly what the cost is, but I think what I'm going to do is when I get into the extension of cloud services for the home lab, I'm going to have costs associated because it's very important to understand the services that I'm consuming in the cloud, right? Whether it's Backblaze or AWS, whatever, and then kind of giving you guys an understanding of what that cost looks like from that perspective, so you guys can know exactly what services are reasonable, what services you should be looking at to really leverage the cloud and extending your lab. It's hard to extend the lab into the cloud and have compute always on. That's where you get hit, right? So anything that's always on from a compute perspective is where you get really hit with resource costs. If you can have something that's not always on and you can spin up, right? Or you can just use the cheaper versions of storage like S3, S3, infrequently accessed, and moving down the tiers of S3, right? If you can start using some of those services, that would be beneficial to you from a cost perspective, right? Anything again with compute though is generally speaking fairly expensive for home lab use. I have ran some Azure services that were, I say my Azure bill is probably $100 a month. The AWS bill is probably, I don't know, I want to say $40, $50 a month. But in Azure, at the time, my bill was $100 a month. I was running AKS services and doing some of that. So I cleaned that all up. I still have my Azure, my GCP account, but my AWS is where I'm connected to, my VPN connection from internal from home. And again, we'll review that at a later date as far as connecting to cloud services and extending the lab. So I want to say that's pretty much it for now. So we covered most of this. QNAP again is running all of these things. DCO2, it's a hybrid NAS, basically running file services, basically more archival or permanent storage, right? Which then gets backed up to Backblaze. And it's running this one VM and container. I like to actually add container station in here for the Uptime Kuma, because I had Uptime Kuma on the Proxmox server. That's moved to the QNAP NAS. Haiku will be running on the core nested CE instance for backup. NCM is running on Proxmox on this nested instance of CE, so that's there. NUS is moved over to the MS01 cluster running there. NDB will run on the nested CE instance. Homepage is going to be something I'm going to do at a later date. It's basically a home lab dashboard where I can connect to my services very, very quickly. I can organize them, put icons to them and just click on them and get access right to those services through one website. That's something that's a nice to have, something I don't actually need, but it's a nice to have, so I'm going to work on that later. Prometheus was swapped to InfluxDB for telemetry. I still have to set up Loki and point all of my logging to Loki. Grafana is already set up. I just have to add more data sources, right? But I have to get Telegraph configured. So Telegraph actually has to be added to this list. TrueNAScale is running. I have to start sending the main footage to TrueNAScale, and I haven't done that yet. Right now I'm still going to the QNAP NAS, so that's something I still have to do. DCO1 is still there, right? And by the way, people ask, like, what licensing are you using for Windows Server? I'm using the demo license, which you can rearm 5 times, right? So if you can rearm, I want to say 4 or 5 times. If you can rearm it, you get 180 days every time you rearm the demo, right? So that's essentially 2.5 years, right, of the environment staying up. And at that point, I probably would have moved on to something else, right? So again, a lot of folks have AD in their environment, and that's the reason why I'm using this. So some people ask me, why don't I use an open source directory service, right, or in a DNS service that's more open or different tool, right? Some folks have asked me that, but the reality is most folks are using AD, right, in the enterprise, and so that's why I leverage AD in my home lab. Again, the idea here is to not become an enterprise, but to closely try to mimic it as best as possible. And having said that, there's a lot of other things that I have to start looking at um, for third-party solutions, such as IPAM, right? So right now I'm using Nutanix IPAM, which is very convenient, but most folks won't be, an enterprise won't use Nutanix IPAM. They'll have their own IPAM solution. They'll have automation solutions like Terraform, Ansible, etc., which I have to set up. And I do plan on building a code server, which will have all of that implemented within, as well as run Visual Studio. So a code server will allow me to actually have one location to access Visual Studio Code, have all my automation, right, connected to my Git repository, which will remain local, by the way. Okay. I know a lot of folks use GitHub, but that's not the reality in the enterprise either. Most folks do not use GitHub. They use Git, a local Git repository. And so it's something I have to set up as well as CI/CD, like Jenkins or something like that. So I have to think about these things as I move up the stack. But I have a ways to go before I get there. So again, I hope you enjoyed this Labor Day weekend update on the home lab around the core services. As soon as I get the NKP bits, which I've already started to download, we're going to start getting into deploying Nutanix Kubernetes platform. We're getting into going to get into how to integrate the data services within NKP, and that'll be the start of the Kubernetes solution for Nutanix on Nutanix, right? As the opinionated stack on Nutanix, so you guys can see what that looks like. And so that's kind of the next step in the next post that I'll be submitting. I hope you have a great rest of the Labor Day weekend. I know it's only Sunday. You have a couple days left. I know my kids are starting to go to school on Wednesday, so again, I hope you have a safe school opener. If your kids are already back in school, I hope everything worked out okay. And as we move into fall time frame and winter, we'll have more time in the home lab as we try to enjoy what's left of summer, right? The weather. So again, hope you have a great week, and I'll talk to you soon.